So in this example here, we have a little bit more complex of a diagram. We've got three vectors, A and B and C. We can also call them PQ, QR, and RS. And if we were interested in finding what vector PS is, that would be the vector that starts at P and ends at S. That's my vector PS that I just drew. And you can get to vector PS. You can find the resultant by adding vector PR, that would be this vector here, PR plus RS. So that's like one way of getting to vector PS. And you can think of vector PR as A plus B. That is vector A plus B. This is, let me even write this in as, this is vector A plus vector B. So that's one way I could have gotten from P to S. But there are other ways that you can go around these vectors to get from P to S. So we've already shown what this is, what A plus B, the quantity A plus B plus C is. That's this. Here's A plus B plus C. Let's show that that's equal to this one right here. Let's go a different color. We want to see what the vector A plus the sum B plus C is. So it's kind of like we're changing the order of our summing or of our addition of these vectors. So let's look at what vector B plus C would look like. First, I want to use the diagram to show that vector A plus B plus C is the same thing. So B plus C would be if I'm starting from Q and ending at S. So B plus C is this vector. Let's even label that. This is vector B plus vector C. And I want to begin my vector with vector A. And that's already given to me in this diagram. That is this vector here. So this is A. If I add vector A plus vector B plus C, what do you know? I begin at P and I also end at S that way. So right there, that shows that there are two different ways that you can start at P and end at S. We would say that this is associative properties of vectors. You can add them in different orders and it still is going to end up being the same thing. You can group your sum of vectors any way you like. We're going to come out with the same resultant vector. So using a similar type of strategy, I want you to take a look at the next problem where you're going to show that two vectors are equal or two vector sums are equal to each other. So give that problem a shot and then resume when you're ready to see how that looks. All right, so here is the UTry example, and what I've done is I've drawn vectors P and Q, and I've drawn vectors Q and P in different orders, but we find that the resultant is still the same vector. They might be in different locations, but it still is moving to the right 5 and up 1. So the vectors P plus Q is the same thing as vectors Q plus P. So vectors are also, the technical term is commutative, in that you can add them in different orders and you still get the same resultant. In the next video, we're going to talk about vector subtraction. So we've done a whole bunch of adding, and it's just slightly different to subtract these vectors. So we'll check that out in the next video.